Introduction. This model is structured, ordered, interrelated, and consistent, which is all signs of a good model. This model explains geologic mysteries, for example, tectonic's driving mechanism, Nastapoka Arc in Canada, Bermuda, hotspots in general, microcontinent of Zealandia, microcontinent of Greater Adria, relative ages and ages of the Earth's layers, the mid-continent rift in North America, the North America Mackenzie Dyke swarm, gravity anomalies, magnetic anomalies, fault system interrelationships such as the New Madrid seismic zone, and even the Theia impact. This model explains all important chronologic geologic events. This model agrees with aspects of the current model, and if not, can explain how the current model came to be. This model is supported and initiated by the results of a 5-year field study in Lower New York, USA, and by an intense analysis of Google Earth. This model is verified and guided by many amazing fractals in North America and around the world. Google Earth. An intense analysis reveals the following about land masses. They are related geologic structures, some of which have broken up. There were 7 landmasses structures. One has disappeared into the Earth. They are presently attracted to a zone between India and Russia. They show details of internal stress and flow-like movement. They show details from amazing fractals within them. For example, history of internal stress and flow-like movement, history of high-energy tectonic geologic events, faults that are based on the character of the fractals. Google Earth findings, shown in the following. William Pagano's January 2019 YouTube video titled Plate Tectonics, Unraveling the Truth on the William Pagano channel. Refined and in much greater detail in the PDFs found in the link below. To see all the PDFs, be signed into a Google Drive account, otherwise you're not going to see all of them. The link above is also found at the end of the YouTube video description. The amazing outer space refolds, part 3 and final part of this presentation. So the next few slides are very critical. I'm going to talk about what is basically Rodinia. I call them outer space refolds because Rodinia made its trip with its full cone section and everything. It made its trip, as I've discussed in the previous presentations, it made a trip from grasping the moon in orbit around the inner Earth, releasing the moon, and then making the journey to the inner Earth and forming Rodinia on Earth as we know it. And it was separated into subdivided crescent-shaped moon refolds as part of the, the chain structure when it comprised all the refolds. It was what I've been referring to as a chain structure. So you can say that these are also chain structures, but they're basically mimicking the character and actions of Rodinia. So here we go. Most have a cone, a top cone, and all have 2 legs, but shapes vary somewhat. Just like a human being, we're all built differently. Below the cone section can look quite human-like. That's why I had to bring that up. You're going to see incredibly human-like fractals. They are shown during or just after high-energy events if associated with tectonic events. That's what this is all about. I've been guided by these fractals, which are just after these major events and everything, so it's all piecing everything together for me. They're visible on many different scales, but often only on certain scales. So there may be a time when you freak out because you can see one pretty clearly. And then you go back to it later on Google Earth and you're like, where'd it go? So these slides will help you at least make you understand how to find these things because they're not always easy to find. They're more visible with certain lighting, angles, focal points, and pixels. So really important, pixels. Sometimes it's actually easier to see them when everything's blurry. And you see the basic outline, and they come out, and it's really, really freaky. It's I'll never forget the feeling when I developed a lot of these drawings, and I couldn't see anything, and then I just changed the one of these things, focal point, angle, scale, whatever it was, and all of a sudden they just pop out. Movement phases are often present for an entire refold, the whole body itself, and for sections of the refold, such as the legs. Particular refolds and particular positions are repeated everywhere. Be like, oh, I remember this guy here, or whether it's the same one or a different one. You see these common positions and stuff. Some areas contain seemingly unlimited refolds. I mean, there's like a city of these things sometimes. Very, very, very crowded. Looks like a rock concert or something. I put in the drawings, I just put in the most critical, most obvious ones. Refolds are drawn into fault zones, such as the one at Yellowstone National Park and the suture zone to the inner Earth areas. They are either parallel or perpendicular to the faults when they get very close to the fault. And sometimes you could see them doing like backflips and somersaults into the fault zone. It's really wild stuff. Really interesting. Refolds are also drawn into ductile rotational zones, essentially ductile fault zones. So it's not all about brittle faulting, which you see on the crust of the Earth that is brittle on the top section. So there's a lot of value to these things because they can show you like where the energy is, so to speak, or where the deeper faults could be. Boundaries are often shared between refolds. You'll see one next to another sharing the same boundary. That's what I'm saying. Refolds occasionally show crease lines for bent leg sections. So it's this 3D thing going on, which makes it even more wild. They formed relatively recently and overprint all geologic history except areas of recent erosion or continental drift where they are truncated. This is probably the most interesting thing here. They just, like I said, they overprint everything. So they had to have formed thousands of years ago as opposed to like millions of years ago. And I know the surface of the Earth changes pretty rapidly anyway, but that overprinting, it doesn't matter what the mapping is or whatever. Some areas, they might not be as clear because of like a sediment cover or whatever it is. I saw that in some areas. Like the refolds were more easily seen, and then I hit like a zone where the zone follows the general trend of the formations. And I think it was non-rock, it was sediments, and I couldn't make out the zone there where the refolds are. So that's the case, but basically everything's overprinted. You can see that, just only erosion. So it's almost like defying science. Very, very strange. Some refolds are relatively easy to see, others are difficult to see. Some slight distortion occurs occasionally, depending on the view focal point. So again, it's like a 3D thing. Sometimes you'd see like one character, in one particular view, so to speak, and then you see the same guy nearby or somewhere else. And it looks a little different. It looks the same but different, but it really depends on that focal point, really. So you'll see that a lot. Refolds define shorelines and fit the land as though it is in the DNA of the land. So sometimes this is such a powerful thing. It kind of goes hand in hand with what I said previously about how these fractals overprint everything. So you'll see how the shorelines and all actually form the shape of these Rodinia, with the cone and two legs. You'll see that they form the shape of these things. It's really, really cool. Refold borders are defined by discolorations in the vegetation, streams, ridges, lakes, and any combination thereof. So this is important here. This is basically a visual thing. So whatever it is visually, these things are distinguished. Refolds are readily found nearly everywhere in the world and on many scales. So there's some absolutely huge ones that take up like a big part of the continent and everything. And there's some tiny ones that you only see with, blurry pixelation. Kind of cool stuff, really, every scale and all over the world. Refold PDFs are found in the link below. To see all the PDFs, be signed into a Google Drive account. Otherwise, you're not going to see, you're only going to see a fraction of them, and it's going to be confusing. Okay, so Rodinia is a interference refold, and it has the form of what I'm circling here, this yellow basic form here, this sort of starting point here from a refolding action. So refolding could yield a form in plan view like this, or more tightly, like Rodinia, basically, like that. And because of the nature of fractals, basically, things can be subdivided. So in profile view, on a large scale, this profile looks like this. There's an open end and there's a closed end here, and there's an open end here. So in reality, I'm going to the lower corner now. In reality, this thing could look like this, which it does. So it's those little, these little subdivisions that cause these refolds here. And those refolds, those subdivided refolds, crescent moon shaped, are the 7 land masses that are on the Earth, originally all connected in a chain, all in a row, as such, you know, all connected like that. So they later got subdivided, but anyway, point is, originally there's an open end and a closed end, but these things, because of like the basic principle of form and function, they became more three-dimensional, they had more depth to them. And keep in mind, all the edges, they all sealed up and everything. But apparently there's enough weakness on the open end over here, and that's the this end here that I'm highlighting. That was there was material and all that was able to migrate through there as the cone led the way, and based on the energy and everything, these things always follow the direction of energy through the cone. So what happens sometimes if there's like a pulling direction, the crescent moon refold that I'm drawing at the bottom, it would develop an arm on the open end, always on the open end. So that's why that's important, this open end, closed end kind of thing. But keep in mind, these things do have depth. They're three-dimensional. And just like a human body, almost like literally, they're built for a certain form and function. So when these things were in outer space, migrating, when Rodinia was migrating to the inner Earth, it had to be aerodynamic and everything. And it probably became built just like something that needed to be aerodynamic. So finally, just keep in mind that these fractals, in general, they're going to show high energy events, such as this right here. We've talked about this. This is when Rodinia, outlined in yellow, released the Earth's moon, and it was together as a double chain structure in orbit around the inner Earth, and it released the moon and then made a journey to the inner Earth. So all these outer space fractals, I call them, I'm saying they're about representing about 900 million years ago, when there was probably a whole zone of these things that were became separated. A lot of Rodinia shaped things, I'm saying, that have a cone top section I'm drawing on the left, and 2 arms like this. So they all went flying, and they just following the energy to wherever they're going. And on these fractals, there's different tectonic events and things going on. So they're expressing that energy through their character and form and everything. Okay, so this is that same fractal we just saw, energized version of Rodinia. So you'll notice I put in the yellow border around things that I just discussed in the slides discussing how you find these fractals. You see like edges of lakes here that I'm highlighting. All right. Now sometimes it's just plain clear. You don't, even without the lakes, you can just see them. But here's a, sometimes it goes right through lakes, whether it's on the edge or right through it. Here, so I'm just drawing these in right now. So this one I only showed one phase. I could have shown multiple phases, and I'll show you where one of them is. So you see a lake here, and you see a road. Now I'm going into the road here. A lot of times they build roads on like areas where it's not so hard to construct something. So that's why they chose that, and it follows the outline of the fractal phase over here. Then you come down like this. I see a discoloration here. So there you go. There's that one phase. Now, over here, I can see something going down. Here's a lake here. So there's something going on here. I'd have to take a really good look at it to draw in this area on the left better. But there's a definite phase thing here, probably like just before the one I drew in the yellow. So that's just an example of how you can pick out these things. See, in this case, it's going through the yellow boundary is going right through a lake. There's nothing wrong with that. I mean, you know, I saw discolorations or whatever going this way, and then you know, edges. There's actually a lake right here, so it goes right through there too. But there's a thin one, so a lot of times they're elongated in the direction of the border. So this guy is in Minnesota, United States. Okay, so this is 3 fractals of Rodinia just after it released the Earth's moon. When they were together in orbit around the inner Earth, it released the Earth's moon, and then it would begin its journey to the inner Earth. So anyway, lower left, this is Maine, USA. And this is interesting because usually you see the other view looking at this way. So this is kind of a rare view where you see that movement, you know, going this way. You can tell by the headwinds and tailwinds, the direction of the tips here. You can tell that there's motion that way. So anyway, there's the one. The main featured one is New Brunswick, Canada. Looks like a dinosaur footprint. There's actually other phases here. I just drew in the most clear one or whatever. And then the one on the right is Minnesota, USA. So they're here for comparison. Okay, so what we see here is Rodinia releasing the Earth's moon in different phases. On the far right, we've talked about this before, where I'm highlighting now in purple. That was when the arms were closed, Rodinia. And then it's in orbit. It's embracing the Earth's moon. It became the Earth's moon. It's in its section in here where I'm highlighting with the arms. The Rodinia's arms are closed around it for stability. It's rotating around the Earth. And interestingly enough, there's actually a direction that I'm circling of the orbit. And that's known because of the character of these n-echelon structures, which are shown in red, going around that elliptical orbit that I'm highlighting. So we know it's in that direction. And the arm of Rodinia, both arms went up, and this arm is longer here because it was in the direction of movement. It's sort of like application of the brakes. It needs like a stronger movement up on that side as it's releasing the Earth's moon and kind of pulling it. See how it's pulling it in that area. It's stuck to Rodinia, probably developed some cohesion over time. The inner Earth is in blue, and there's a attraction going there. You can see the center line is lining up with what became the Earth's equatorial spin axis. So I think the fractal's trying to show something there, that there's a relationship between the fractal on the lower right and that one on the upper right there. And incidentally, there's even structures in there that are consistent with the movement. There's more n-echelon structures that indicate that after the asteroid impact occurred, there was ripping out of the arms of the Southeast Asia Refold, which is a subdivision. There's 7 subdivision or landmasses or continents that were inside of Rodinia when it got to Earth. So even the structures are consistent with what you see in the fractals. And I should note that fractals that connect in time, that advance over time, like the lower right one that shows Rodinia releasing the Earth's moon, that's one. Then the upper right is the whole chain. So that's, I consider that a second one. So the time sequences always go in counterclockwise direction. So that's really interesting. There's actually one, if you look at the upper right, there's a separate fractal here where I'm highlighting. That's just after that chain below it. And again, to note on this, I actually find at least six phases of the history of Rodinia between maybe traveling before Rodinia got to the orbit around the Earth. There's this aerodynamic shape to it I'll discuss later. And then it's in orbit, and then it releases the Earth's moon, and then it's on the way to the inner Earth. Okay, this shows 6 phases labeled in chronological order of Rodinia. And I won't get into detail again, except to note that that blue line, I'm not just drawing a blue line there because I want to. There's actually lineation seen. So that sort of indicates a dynamic there that Rodinia sort of bulged out into the view of the viewer. So you see between 3 and 4, for example, there's a slight counterclockwise rotation and a bulging out. Okay, so this is Northwest Territories, Canada, the main featured fractal. The fractals on the lower right were discussed in the previous slide. Those are 6 phases of Rodinia. So there can actually be a 7th phase right here that's outlined in blue. You'll notice, first of all, that peninsula is formed by the fractal, and you also notice that the borders are shared between the blue fractal outlined in blue and the one outlined in yellow. So what I suspect is that this is actually aerodynamic phase of Rodinia embracing the Earth's moon on the interior, which is over here. So I'm talking about the one in blue. So it's got the same form as number 1 on the insert over here. That's just showing the attraction to the inner Earth when it's orbiting, showing the nose of it is being pulled into the center of the Earth. So this one looks like some kind of just like aerodynamic thing where it's traveling in this direction that I'm drawing here. See how it's designed aerodynamic? You know, the top hat is the back of it and everything, so the airflow is real aerodynamic there like that. Okay. That's what I suspect, but it could also just be basically the yellow fractal, one outlined in yellow with the legs extended. Now the weird thing about the yellow fractal is it doesn't show the top hat. So for whatever reason, it could be out of the view or whatever. I couldn't find it on this fractal. So it's just something weird going on. It makes things a little more confusing. If it had the top hat, then we would know for sure or more clearly exactly what's going on here. But realistically, this could be the first initial phase because these fractals show high energy events and stuff. So an aerodynamic traveling to try to reach the orbit around the inner Earth is, you know, there's a lot of action there, as opposed to showing a fractal of something just in static motion, which is the orbit around the Earth. And actually it would be bending probably towards the inner Earth, like it's shown in the first fractal in the time sequence on the insert below. So I suspect this is the aerodynamic phase. You'll notice the what represents the moon outlined in magenta. There's also interior, you know, it's composed of refolds that are outlined in red, putting a check where I'm talking about. So you see that. And there's actually some deformation more in this area as opposed to the other part. So it was being squeezed by the Earth. As you saw, it was even squeezed in the first phase of the insert below that we showed on the previous slide. Okay, this main featured fractal is in New Hampshire, USA, and outlined in blue. That's the one I'm talking about. So it appears based on the details that this fractal in blue is between phase 3 and phase 4 on the insert on the upper left here. So I found a few of these like this, sort of just supplementing these basic occurrences that are shown in the insert. And the reason I know it's between 3 and 4, first of all, you can see the subdivisions that I show. And again, those are lines in the fractal. I'm not just drawing these things, and I'm highlighting now here. That's shown as such. And these things are shown in both 3 and 4 on the insert. Based on the character of that and the character of the overall body, the refold in blue and the ones in yellow, the insert, I could tell it's just after 3, because in 3, there that upper subdivision where I'm highlighting here, that is pointed as if it really just pulled up in that direction, and then it snapped back a little bit between 3 and the insert and this featured one in blue, because it's more rounded there. It's more rounded right there. And you can tell that there's, it's coming up towards the viewer from 3 to the blue one featured, because you see the character of the legs showing more of a tailwind kind of movement in the direction of the viewer. So it's after 3, and it's before 4 because there's a greater movement towards the viewer in 4. It looks like it's really blown out, and those divisions, those subdivisions, I could even highlight it now. If you look at the upper left, these two things are now they're further to the south, and it's indicating more of a blowout kind of thing going on. I'm highlighting this center line, so that's like going towards the viewer, and there's possibly a little bit of a counterclockwise thing going on also, but it's evident that this is just between 3 and 4, this one featured in blue. Okay, form and function of the refold chain structure. This has been discussed before, but you can see that there was a function of grasping, Rodinia grasping what became the moon. So it created like a bell-shaped structure that I outlined in blue, similar to this claw crane machine over here in the upper right. So you see that that kind of bell-shaped structure, and you see like that notch created also. The upper part of the bell shape is showing like a notch. And again, that see that notch was formed quite distinctly in that fractal from Nova Scotia that I was discussing on the previous slides, and I'm now highlighting that notch section here. See? So that's where it developed. So these refold structures are very adaptable depending on what kind of energy is going on, and there's some apparently some permanent or more permanent deformation sometimes. This is just an example here of fractal in Maine that shows that bell-shaped structure and the notch too. So you see the claw crane, and you can compare the two. Okay, this huge fractal in New Brunswick, Canada, and Maine, and part of New Hampshire. It looks like it's cut off by erosion here at the bottom. A little bit anyway. A lot of times you can see a lineation in the ocean or whatever to connect the lines to draw these fractals, but it looks like it's just starting to break up there in areas, and you'll see better examples of how refolds were lost to erosion in part, indicating they're quite young. But this is just another example of the form and function. You can see the bell shape similar to the insert and the notch in the middle. Okay, this fractal is in Northwest Territories and Nunavut, Canada, and it shows similar character. The main featured fractal in yellow, and also another phase shown in magenta. Those fractals are very similar to what's shown in the insert, this release of the moon. And sometimes fractals, as you saw it actually in one of the previous slides, sometimes they, actually a couple of the previous slides, you see that a lot of times there's no top cone section. So you can see that here in the blue and the red guys over here. Now that, you could say that could be due to the view. It could be, but I know that I'm sure, based on what happened in reality, a lot of them probably did lose the cone, because that is the most unstable part of the refold structure that would tend to disappear. Okay, this is another pretty big one in Maine, USA, and New Brunswick, Canada. The top cone section is either not seen based on the view, or it has been lost. So this is probably the most boring slide in the entire presentation. Okay, in this fractal in Newfoundland and Labrador, Canada, and Quebec, Canada, You see the refolds don't have cones again. And a lot of times what you find is like certain clusters of similar refolds develop without a cone or with a cone or whatever. And a lot of times they, there's many similarities between them. They're like family or whatever. And perhaps they sort of represent how they came from one area or whatever. And they underwent the same changes because they have the same characteristics that are inherent or whatever it is. So again, I don't always draw in the all the refolds. I just put in more clear ones or whatever. But if you look at this, if you look at the upper left, I see a rear end here, and there's a river here that forms the border. So just drawing it in, I see the other side here, and I see something going on here. I think they come in like this. Something like that. That's just a very rough version, but that could be, I'm sure it is, another refold. It's not drawn very clearly. It's just a quick thing to explain that, I can pick these out after doing this for a while. And again, sometimes it's more easily to do than other times, but I could see that one there. And actually, I see another one too. Let me do this one in purple here. I see there's one over here. More or less. So I don't know if you can see that. So there's like, groups of these things typically. Okay, you see a bunch of refold structures here in Wisconsin, Minnesota, Michigan, and Iowa, USA. Some things to point out here. I'm going to circle this little guy here in red. His whole body is forming that coastline there of the Great Lakes. So it's like I said, a lot of times these things, it's almost as though the DNA of the Earth is these refold structures. So another thing, sometimes, like I said before, where I'm highlighting the outline of a fractal is underwater, within the water. So that's what happened in this case. So it's not like I drew that in there because I wanted to. You see that a lot. So here's another, this magenta one right here where I'm highlighting. That border forms the edge of Michigan. Okay, so that's a perfect example there. Now, with this yellow one nearby, I'm highlighting the yellow leg. There's actually a phase thing going on. The first phase was the yellow, and the second phase was blue. I know that because if you look at the nose that's leading the way, this thing's taking a right turn, so it's got to go from the yellow to the blue. So many of these guys are attracted to something. You look at the where I'm circling that nose there, this nose here, the nose of the one I was just talking about here. This guy that I'm checking, the magenta one, he might be into the page, so to speak. He might be in something, or he's just, for whatever reason, there's no top section shown. But it looks like there's some kind of thing going on. Even the feet of this guy, they're all drawn into something, except for this is Rodinia here. I'll talk about that in a minute. But they're all getting drawn into something. Now, the Great Lakes was a rotational feature, and it still is, whatever. It's a lot of counterclockwise rotation in there, and there's a pivot point right over here. So everything's rotating about that point, and maybe these guys are just getting drawn into the rotational zone. Because like even this guy right here, just kind of looking into the zone. Or specifically, there's something right over here. It's really hard to say, or both. Could be any of that, but there's something going on here. As you'll see later, there's actually like a ductile flow zone going right through here. And I'll get into more detail later, but I'm not sure if that's at least in part causing the attraction. One thing I should note is in drawing these fractals, you'll notice that the feet always match. That was kind of an indication that I'm drawing the fractal correctly. The legs are always the same length, and it should be noted that I always am confident in what I draw. I take my time, I check it, I draw what I think is the best representation of the fractal and as accurately as possible. So back to this one here in white. This is Rodinia, a good representation of Rodinia when it was traveling to the inner Earth. There's 2 weak zones shown in green here and shown in pink. So that's where it lost its top hat. I'm thinking here, but it's really hard to say. And fractals mimic tectonics. There's Southeast Asia refold here. That's what it looks like when its legs are tucked down. But when its legs got yanked out after the asteroid hit, you saw them curled up nearby as such, like this. They got curled up because they got yanked out and then it snapped back. Well, this is showing from white to red to blue. It was like a coiling in. And with the coiling in, it kind of made this bulge here too in the middle. So there's like a mimicking of fractals here. Okay, this large fractal in Maine, USA. Here's an example of how young these fractal depictions are. They represent 900 million years ago, but the actual fractals are on the order of thousands of years, because you can see this erosion here, or in part due to continental drift of Nova Scotia here. This is Nova Scotia, Canada. So quite young, these fractals. Okay, this is that same area as the previous slide. There's a new fractal shown here. You see its one border is a river, and it's on the edge of Wisconsin over here, more or less on the border. I'd like to just talk about something more with this white fractal here, which is a good representation of Rodinia. So I said compare all these fractals. So not only, I talked about Southeast Asia here, how it's mimicking other fractals and mimicking tectonics essentially with that leg, both legs coiling in, showing that action there. There's also the weak zones here in the cone of Rodinia. I'm highlighting one. There's a lower one and an upper one. So you can see those zones in the inserts of other versions of Rodinia. There's upper and lower weak zones. And we saw these phases before. So then you see this one over here where I'm checking up on the top. And that one either lost the cone or it's just showing a view where you can't see the cone. So just speculating that the cone had snapped off at one of these weak spots. And whether it's the lower or the upper one, I'm not sure. I tend to think it's the upper one because the refold just below the border, whatever border that may be, is the Russia refold, and that kind of fits oddly. So perhaps it's the Russia refold is on the bottom of the upper weak spot, and then it's kind of just not very well bonded to the North America refold, which is below it. And those bigger ones, at least the longer ones and all that, are North America and Africa. So I think they're in the section below the lower boundary, and Southeast Asia is the one that forms the legs, or at least most of the legs. So you can see that fractal that I was talking about in the lower insert here that I'm highlighting now in red. That's Southeast Asia. You can see that bulge there that I was talking about that I'm now highlighting. And there's the legs that coiled in from the action, which is, there's these en echelon structures here, so you know that there was a whole dynamic going between the legs yanking out and the center line of the chain getting bent counterclockwise, which is shown in blue. So again, the fractal mimics tectonics. It mimics other fractals and what actually happened. So there's another one here of Rodinia that I'll talk more about later. And this one only shows one weak spot, at least clearly. And I believe that's the lower one. It looks like it's missing this top one I'm highlighting. Oh my God, look at this. Wow. Hudson Bay Canada, 900 million year old refold structure fractals. These guys look like the same guy, or very, very related. And like I said, the fractals a lot of times share borders. You can see that where I'm highlighting now, right here. Okay, and here also. So they're like sharing this leg. And there's that whole three-dimensional thing. I didn't put it here, but there's like a line here. There's this here, this here, this here, and this here. So there's 3D kind of bending thing going on. And these guys are actually in a fault zone, as you'll see later. They're oriented in such a way because of the fault direction. Okay, this is Hudson Bay Canada again. There's several more fractals not shown as typical, and are on several different scales. Even the ones that are shown are on different scales and all. And you can see the border sharing and stuff like right here. Nothing particularly interesting to talk about here except this here. The location of this fractal in the Hudson Bay is where it's shown with the arrow here. And fractals are not readily seen in the mangled islands of this whole area. So that's something interesting. Okay, this is the Mid-Continent Rift, and these fractals are in Minnesota, USA. At least this one here, both the ones on the left. Basically, I won't get into the details, how it deformed and all that, but you'll notice the bell shape, based on the form and function, the function of grasping the moon and keeping it in orbit around the inner Earth. And when it released it, it kept that inherent shape of the bell shape. And it, as you saw, a lot of the fractals even still had that notch and everything. So again, something, I've talked about this too, but something very interesting is this fractal that's in the lower left is shown in the small circle in the upper left that I'm highlighting here. It makes like a slow transition to the yellow fractal. And it's showing signs of like going into like tough headwinds and all. And there's that putting on the brakes kind of thing in the front here I'm highlighting. So that resembles the Lake Superior kind of thing going on here. I think if it wasn't covered up in the front, Lake Superior would look just like that. It would curl up like that I'm highlighting. So just interesting because, again, Lake Superior, if you look at the published study insert on the right, Lake Superior is in this area. So there's like a connection going on. These fractals are trying to tell you something, you know what I mean? Okay, another example of fractals sort of trying to tell me something, trying to tell us something, is if we look at this magenta fractal that I'm highlighting. This is the center line of the MCR, fractal of the MCR, and this is in Minnesota. It's much larger than the one that's in the lower left. So there's a bunch of them in the area. It's also in Minnesota. So there's a reason it's there, and it's related to the blue fractal of Rodinia because the MCR was found on one of the legs. It was on one side, and that's why the pulling direction when the thing extended, when this Rodinia extended to grasp the moon, the legs extended, and there's deformation related to that. But that deformation is recorded in this structure that I just highlighted. There's this snapback, so you can see the pieces got broken up and snapped back, and there was kinking and everything from compression going up to the north and to the northeast. So what you have here sort of mimics in form. It mimics this this fractal in blue. So it sort of strategically finds a place there, or like the general trend of the lineations in the rock or whatever it is are matching. So, I mean, I don't know how to describe it better. Just it's very strategic, kind of like how the fractal in the previous slide, the MCR, transitioned. It's just very clever how it does it because it sort of matches things. It's like it has a mind of its own and it says, okay, this is a good place for me to be because look at this fractal already. It's kind of close to what I'd like to show you here. Okay, this is kind of a supplemental slide to the previous one. Just want to talk about a few things. First thing is miniature refold fractal right here. This was on one of the inserts of a couple of versions of the same thing, which is showing Rodinia had just released the moon and snapping back, and it's about to go on its journey to the inner Earth in space. So this fractal in blue that I'm checking, that's the representation of Rodinia on its way. And if you look to the right, where I'm circling, those are the two different phases during the process. Now, the one in yellow shows something interesting. The location of the MCR is shown in magenta here. I'm about to highlight. And with the snapback, there's those yellow forces. See one going up to the north-northwest and northwest and one to the northeast. So being that this is in the same area, it's kind of showing us something here. If you look at, first of all, I drew the previous phase here where there was no deformation from the snapback yet. Things were extending to the southwest, probably went further, but they went down like that because that leg was over there that I'm drawing on the right side. It was embracing the moon. So then it snaps back, and you see the centerline diagram over here becomes disjointed. There you see the pieces came off. That's because of this snapback in this direction. And then you had another snapback component in this direction. As you can see, if you look at that yellow diagram carefully, you'll see that. So from this snapback here, you have the disjointing from this one. And from this one, you have the kinking here, here, and here. And it even is kind of flat there. So all these fractals are related. They're near each other. They're kind of telling you something. And I just find that very interesting. So actually, you know, in conclusion here, if you look at this blue one, everything's strategically located because if you look at the form of the blue one, it's sort of similar to the centerline diagram that I show that's disjointed here, right within it. It's inside it. So it's just strategically located, the MCR, to kind of mimic the shape of the Rodinia fractal in blue. Okay, this is fractals in Nova Scotia. Looks like family of them all within each other there on the left side with no cone and everything. There might be some rotation. If I had to guess, I'd guess clockwise, but not necessarily. You can see some kinking in the legs. It just could be the view, like I said. Just the focal point is sort of deceptive. It could look like it's bent there, but it may not be. That's not critical anyway. Basically, what's interesting here is this one with the cone to the right. It lost its legs, which had to have been like, you know, not that long ago. It's on the order of thousands of years or whatever, because these fractals are all very young. They overprint everything. Now, Nova Scotia did drift up to the north and east off the mainland of North America, and in the process of continental drift and or erosion, apparently, and also maybe some sea level rise. But I don't see the lineations this time in the ocean, in the water. Sometimes I do. In this case, I don't. So then it's therefore probably tied into continental drift more. Okay, so these are fractals in the Adirondack Mountains in New York State. And what you see in yellow, the large one is excited version of Rodinia when just after it released the Earth's moon. Legs went up in the air, bounced back. The one in the red is the East Coast subdivision of the North America Refold. You can see the Mississippi and Ohio rivers shown in blue. And there's like a lineation there on the fractal too. And you got Mexico on the left side that I'm circling. And you got New Brunswick way up here. Florida is shown nice and clear right here. All right. And the blue one is Rodinia also without the cone, without the top section. And you're going to see an energized version of that in next slide. Interesting stuff. Okay, so this the inset is what we just saw on the previous slide. And what I'm showing now is this large yellow one. And it says blue fractal and inset is in here. You can actually see, you see the rear end here. All right. Throw it in very roughly. So just to give you an idea how big things are here. Now the next phase, like if you look at the character of the blue in the inset, that blue refold, now look at this yellow one. There's motion going this way. You can see on the blue one, it's relatively straight on this side of the leg, and this is kinked in, and got more of a kink here. So there's some action there. The leg kicked up a little, and now you can see a different angle on the foot as it looks pointed here and here. So I have a feeling that this is shown after the hat was lost. It could also be that you can't see the top hat section, the cone section, because of the view. A lot of things depend on the focal point. Okay, this is a fractal in Ontario, Canada, the main featured one here, Ontario, Canada. The inset is in Minnesota, it says here. So you'll look at the similarity. I said compare these two fractals. So they're both doing that little dance there with the one leg. And it's like I said, these fractals are, they can be far from each other, which they are in this case, but it's almost as though certain actions are seen over and over again. So nature likes this one or whatever, where this little dance is going on. Okay, this fractal is in Iowa, Missouri, and Illinois, basically, and it shows Rodinia. And we talked about this one before. This is after it releases the Earth's moon below, and there's that snapback. So interesting here, you can see the fractal feet match on this yellow one. Shows a multi-phase thing. So you look at the bottom here, almost looks like flippers. You get a different angle there on this foot over here. Very interesting. It looks different than that. Maybe it's because, again, the view. You're seeing more of a profile here, or it could be like a form and function thing. So now it's ready to, before it was embracing the moon, and now it's getting ready to swim, so to speak, so it might develop some flipper action. So anyway, what I wrote in these text boxes, here's that weak spot again. I can't find the other one, somewhere here. I wrote upper cone section that fell off after the Earth's crustal refold structure. The complete structure is shown here. Released the moon in their orbit together around the inner Earth, and then made its way to inner Earth. The inner Earth's attraction was greater than that of the moon, so the structure shown released the moon and headed toward the inner Earth. The blue and yellow legs indicate that the refold structure underwent changes to meet its function. The function of the yellow refold structure was to stretch around the moon and stabilize the joint structure. The function of the structure in blue was to power its way to the inner Earth. Now they may have, the feet may have not changed, but they may have. I could see this changes undergo, based on the function. Okay, we've discussed a lot of these fractals before, but this is just for comparison. The slide we just looked at showing Rodinia. There's the weak spot here, the one in yellow that I'm highlighting here, dashed line. That corresponds to the fractal in white here, this magenta line. And I think there's another one here. You could almost see it, but somewhere in there. So you got, if you look at the white one, you have a small section, and then you got a kink there, and then a curve again. So you got a small section, a kink, and then a curve again. So that's why I put in this one here, but it's not evident on this fractal, on this yellow. I'm just showing these here for comparison. Okay, this main featured fractal is in Massachusetts, USA. We saw what's in the insert that's showing the phases of Rodinia as it dropped off the Earth's moon in orbit, and then it head towards the inner Earth on its journey. So here we go on the text box. Massachusetts, USA fractal of the refold chain structure that embraced the moon's crustal refold chain structure. It had just released the moon's crustal refold structure in its orbit around the inner Earth and is headed towards the inner Earth. The southern section became Earth's crust, and the arms became the locking mechanism on Earth. This fractal appears distorted and may not be as accurate as those fractals shown in the inset. The very top section of the cone may be bent and hidden behind what is shown. Note the heterogeneous character of the refold chain structure between the bottom section, including the arms, and the top section, which is highly divided and shows squeezing at the interface zone between the two sections. Note the notch at the south end of the fractal that is similar to that on the Nova Scotia fractal on the inset. So that notch is, I'm highlighting here on the insert. You see where the moon is in green? So that notch is evident here on the featured fractal here. It's highly divided up here. I remember drawing this in. I saw more of these things going up, but they got really hard to see. And you'll notice there's like a squeezing here. It's like it's being pinched there the deformation is like a squeeze type thing. So in a sense, you see that even on this fractal, for instance, on the inset, I'm highlighting the yellow fractal. There's a little bit of a squeeze going on there in that zone. So this is another expression here. Not as good as the other ones, though. Okay, this is a refold structure fractal in northern Quebec, Canada. And look at the northern end. There's a little bit of lineation out in the ocean to just form that tip there. Just a tiny bit getting eroded. And there's a bit of a bell-shaped thing going on. And that's why I put that claw crane machine on the insert. Okay, here's another featured fractal here in Quebec, Canada. They're both in Quebec, Canada, the one on the insert and the one featured. Might be the same fractal, fairly close to each other, and about the same size too, if not the exact same size. Now, one thing to note, look here, look at this section here. Remember I was saying that things look different based on the view, the focal point? This could be the exact same view, more or less. If you look at the insert one, if you look more on the top of that, you're going to get this view on the left versus the other one. So the legs appear straighter also on the left, but maybe from a different angle, they're going to appear more, you know, like this kind of thing. So anyway, that's just something to note there. There's like another family of related refold fractals here on the right. They don't have any top cone section, and it looks like there's some kind of action that way. It's like a push-off thing going on. Push-off with this leg, and sort of like a apply the brakes thing going on the right side. Okay, here we are in United States, much of the United States. There's some huge ones here. I didn't want to clutter up the diagram and put the ones on the insert, which I'm checking in this main featured area. And this pair, the red-yellow pair that you see in the insert and on the right side of the main featured, that could be the same guys. They certainly look the same. You can actually see a little bit of, on the insert, you can see kind of the feet thing going on, a little bit of lineation there with three-dimensional outline of the foot thing going on. Looks very human in this case, like a human foot. So you also see some 3D stuff going on with this guy in blue here that I'm circling. You can see the bends in that. If you look at the red and yellow fractals that are the excited version of Rodinia here that I'm checking, apparently the movement is this way for the yellow, and I think it's more up for the blue. I don't see a lateral kind of movement on that one. Maybe one went to the other. They're more or less the same size. They could represent the same guy. You just see the ones without the cones in this area, including the big one. Everything's inside each other. Sometimes there's a reason for that. You get the little inside the big. And looks like the big one in yellow is getting ready to go this way. They're all going that way too. And if you look at the one on the insert, these two are like kind of like aimed this way. There's a rotational zone in there. It goes like that, and it propagates up to the northeast and all because of that action of the North America refold going around the impact site. and the pendulum-like rotation went this way, caused like a drag fold there for Lake Superior. So there's a whole thing going on, as you'll see in more detail later. So these big guys in the insert, if they are the same as the ones on the right side of the main featured fractal, they didn't get pulled into the Great Lakes because they're so big. You'll see that if something's gigantic, it's not going to feel the forces so much. It might get a little bit of it as it goes by, as it maybe this one did in the insert. It felt that force of the Great Lakes probably, and then it scooted by and it's off somewhere else on the right side. And just to note, the insert on the lower left that I'm checking, that character in the yellow, the character of him too, is similar to the character of this character, the big one in yellow in the middle of the featured area. Okay, these are very large fractals in Quebec and Ontario, Canada. And I was saying here, in each of these fractals, the legs may appear magnified in comparison to the cone section due to where the photo, so to speak, was taken, the focal point and the direction of the view. So I also noticed that the feet look kind of like flippers again. You see that point right here? And I see that once in a while. And this has the same thing. This guy is probably related. He's smaller, but he's got similar character. Okay, these are fractals in Northwest Territories and Nunavut, Canada. Couple things to note: there's all kinds of different directions that they're headed for different reasons and all that. There's just a hodgepodge again of some ones that I saw in the area. I should note that there's actually a good one right here that you'll see later. I didn't include it here. You can actually see the cone is broken off there. So anyway, if you look here in the north, you see the cones are forming the coastline there. You see that often. You see they're sharing a border, the white one and the yellow one here. These guys are sharing a border too, where I'm checking this reddish one and the yellow one here. And it's interesting with this yellow one above, the the whole crotch area and everything here. You can see that three-dimensional thickness. You can see from this angle, it looks like the legs are tucked in. I'm sure they're tucked in to some degree, but based on this view, it looks like they're really tucked in. So it's just, again, things depend on the view, the focal point. Okay, these are a bunch of refold structures in Alberta, Saskatchewan, Manitoba, and Ontario, Canada, with and without cone sections. There is a energy direction of the pendulum-like rotation that's kind of going this way. The big pendulum-like rotation around the asteroid impact area. And you can see these guys are definitely headed that way. And even showing the look at the red one here. Look at the putting on the brakes action of that front. It's going this way, that front leg. And if you look at the yellow one, there's a and really yellow and red. You see this tailwind kind of thing going on here. So they're it's going back from the tailwind like that. And headwind is still evident here in the front. So it's going this way. And looks like the back is braking on the blue one. Okay, this is several fractals in Quebec, Canada, and it looks like several independent paths are shown, with the front cone leading the way. So there's definitely something strong going on here, where I'm highlighting. Those guys are pulled into something. You can see the bent knee section here, and the turn in that direction. So there's that sort of like putting on the brakes with the left leg. Like, okay, I'm going to turn this way and I'm going to push off with the right. You see that action going on, right? In order for it to go in that direction, it's got to do exactly what it's doing. And again, the yellow guy's going this way and the red and blue are going that way. They may or may not be related, but they're shown at least headed in that direction. Okay, these fractals are shown in southern United States and a little bit in Mexico. You notice on the red one here, I'm highlighting the Rio Grande River that's on the border, on the river, Rio Grande River, which separates the United States and Mexico. So I was saying that fractals often form on borders. Oh, there you have it. There's a big fault, by the way, going down this way that actually pulled the Rio Grande River in that direction. The fault separates the eastern subdivision of the North America Refold on this side versus the other side. There's another Refold section on this side. More on that later. Okay, so there's many different styles here. I was saying compare the blue with the two blue ones. Check it out. Yep, on the insert. This one versus this guy here. There's another Rodinia one in yellow, a large one here, and it shows that weak spot again in the cap, so that may or may not be the break-off point. There's probably another one here somewhere that may be where actually where the cone broke off. Oh, specifically back to these two blue ones that I said compare right here. It might be just different angles, locations, different focal point. Because you notice the leg on this one, the main featured area here, goes that way. If you were to rotate that head on, it would look just like this on the insert. See that? If you look at this head on this way, it's going to look like this is going that way, which you see the leg going that way. So there's that whole focal point thing. All right, this one's really interesting. This is like a police lineup. It's in Panama. Check it out. I really love this one in yellow. Is probably my favorite one. You can actually see the superposition of this cone here coming down. And yeah, it's like a police lineup. They're all like lined up. I'm not sure what this all means. If this is supposed to be the same one or what, but you know, these two guys are pretty similar here. And this whole dynamic between the one and the red, there's like a wind thing going on, like a whoosh, like going this way, like, you know, that kind of thing. You can tell. So God knows what's going on, but very interesting. All right, we're looking at fractals in the northern part of South America here. Some lineations out in the ocean, which I'm highlighting for the big yellow one, is like that. And again, from the view, maybe his back is not distorted. Maybe he's supposed to be like tucking in, and this is just how it looks in plan view. Whatever it is, God only knows. But obviously, his border is forming the coast. It's a lineation out in the ocean, and you see these guys are headed somewhere. They might be going towards the break-off point of the Boudins that was off the mainland in this direction, where the Boudins broke off back in the Paleozoic or whatever. And later on, they got rotated through the Caribbean, different phases that I discussed. So hard to say if they're following sort of a fault zone of movement here. Remember, these fractals like to go along either parallel or into fault zones. So it's tough to say. I mean, at least these ones on the bottom are kind of heading in another direction than this path here on the top. A little different. So it's probably all related, but you know, who knows? Okay, this is the fractals in the southern part of South America. There's some big ones and some small ones, and they're sharing borders and stuff, and looks like different pulling directions. You know, the guys in the little guys in the middle are going somewhere to the right. Being that the break-off zone is here, it's possible that they're gravitating to that where I'm highlighting, but who knows? And you can see that these things vary a lot. If you look at the one in the yellow, that one's really unique. It's got maybe those pointed flipper feet again, one in the yellow. You can see the 3D bending on the fractal. All right, these ones are in Australia, these fractals. It looks like, said note the similarity between the top left fractal, top left insert here, and the small fractal on the right side. They look like the same one. A lot of similarities. So, again, they're all over the place. This is Australia. We just showed South America and Panama, and there's more coming up. All right, coming up on several slides. The most interesting thing is saved for last. Fractals reveal faults, fault systems, and fault interrelationships, both brittle and ductile. Keep that in mind. Okay, in this slide of North America, I'd like to stress that there's ductile faulting, a lot of ductile movement, and what I'm showing here is a lot of ductile features. So if you look at what these yellow things are, these are boudins that were formed in a tension zone originally, and they're still a tension zone, but there's going to be tension on the one side of the asteroid impact here. So that's where the asteroid impact was, and it rotated in a pendulum-like rotation this way to that location, and the North America refold rotated around in that pendulum-like motion, basically along the path of this red line. But this red line that I'm highlighting, that's basically a discrete path that even pulls the boudins slightly into the what was once the compression zone. So again, you got your tension zone on this side because there's this pulling from this pendulum-like motion, and there's a compression going this way from the actual impact of the asteroid. And you can see this feature here. These are all these red folds are like center lines of folds that I drew in. Those are ductile features also. So there's that compressed fold there. It was connected to this one here, and you can see from this SC structure here, there's a shearing direction, so that pulled it that way. And right in that zone here in the red is the heart of that SC structure, so that's why it pulled that way. And so you're going to get your compression from the direct impact, and then you're going to get your compression going this way because it's jamming up against the front. That front is indicated like this, and you can even see it on the Lake Superior here, the one end of it. And I should note, while I'm on Lake Superior, this is like a drag fold, like this. At one time, it was probably curled up like that. See where I'm drawing? It's probably like that, putting on the brakes motion of that front arm, and it couldn't get past this front or whatever. So there's some consistency here, and this where I'm circling now, this compressional fold here, kind of small, and it gets a little bigger here. It gets like real complex in this zone. There's a lot of folding in here, and it's like completely mangled and complex and everything, which makes sense. And so that's the other compression zone. There's the bottom from the direct impact, and then there's the rotational pendulum-like rotation that causes the compression on the east side of the impact. So let's take a look at this discrete zone of the red pathway. You got the boudin pulling right near it as it gets close to that red pathway. You got it bending in here. See how it's coming down like that? Same thing here. You got that going on. And you actually have it jamming up into this end of this tail of the boudin. And meanwhile, the whole boudin itself is actually entering into what was once the compression zone. So it's along that discrete pathway. It's tension because it's getting pulled through. And at the end of the red pathway here, there was actually a push-off, and there was continental drift. This was connected at one time to this. So again, you have this direct impact here that I'm circling, and that's indicated by this SC structure here that I'm circling. I'm now highlighting. You can see that shear direction is that way, so that in fact pulled it off. In this way, it indicated at least that direction going that way, and then the SC structure here pulled it to the right and pulled it into that along that red pathway as I described. So below all this pendulum motion is there's a Great Lakes rotational signature in here that I labeled, and there's a drag folding after the snapback of the this subdivision, this eastern coast of North America subdivision was snapped off over here. It was where Alaska area was connected here, and it snapped off, and there was some skin friction resulting in some drag folding in this area, like by Niagara Falls and all. So that's what I'm talking about there. So the tension direction was this way that I'm highlighting, and it snapped back here. It's even kind of flat in the nature of this the New Brunswick area. It was shaped like this originally, and it's since been eroded and all. But there's evidence of that snapback, and again, the skin friction here, Niagara Falls area. There's evidence of that snapback. And there's internal features too that we discussed that show there was in fact tension and then compression of that East Coast subdivision of the North America Refold. So let me read this quickly, these text boxes, just to reiterate. A pendulum-like movement from the impact in Hudson Bay is evident in that there is compression to the south and east of the impact site and tension Boudin source to the west of the impact site. Boudins formed after North America Refold wrapped around the impact site and formed in the radial tension zone in the western half of the impact zone. The Boudin pulling is accelerated in the direction of the red line around the impact site at the Hudson Bay. There is even compression of the Boudins in the upper reaches of the red line pathway as the red line pathway pulls the leading Boudin through the discrete zone. One other thing I missed here, Greenland is a huge drifted and broken up Boudin. It's on the outside fibers of a rotational zone. And you can see that on a different angle. All right, this main featured fractals here are in Quebec, Canada. Now, the previous slide I talked about that red pathway, that discrete pathway. There is an SC structure here. I'm circling here right in the center. And the main direction in that pathway is this way for that SC structure. So the differential movement is much more in that direction than this direction here where I'm circling. So the result is a movement through that red zone. And this is a approximate center line again, another fold. The other ones were in red. This one's in blue. The previous slide there, red. So I put the center line in, and you can see that I put a blue arrow here that I'm highlighting now. There's that direction of movement that's curling up the end, going into the headwinds like that. So it's curled up like that, sort of like a what I described was the Lake Superior kind of thing going on, where that putting on the brakes kind of thing in the headwinds in the front here is going on. But you can actually see that this fold in blue, the outlined center line of this fold in blue, is actually pulled by, in this zone here, is pulled by that main red pathway that I was talking about. So you can see like two kind of things going on here with the fold in blue. And being that there's this directional movement this way, I know that there's actually a fault in here, and the fault is, put it in purple. It comes through here, and then it goes like this. So you see where I'm highlighting now. There's a fault in that direction. So these refolds are attracted to fault zones, as you can see from the leading section of the yellow cone here that I'm highlighting. It goes right along that fault there. And this is definitely a fractal here. The blue center line of the fold is a structure. I don't think it's a fractal. I noted it's a fractal here, but it's I think it's a real structure. But this is definitely a fractal riding on the back of the yellow refold. So these things are weird, It's blue guy is the little guy on top is moving in the direction shown of the arrow, and it's as you can see, it's got that curl up thing going here, and I'm highlighting now. So the movement's in that direction, and this fault is undoubtedly the one I'm highlighting now. This is undoubtedly connected to this refold border here, where the this section of the North America refold had that snapback and everything, and it flattened out the top part of the arm, and Alaska went that way and went all the way around. So anyway, there's actually several faults in this area. Now, if you look at the insert, the area of all these, of all the action is in the yellow circle here that I'm drawing an arrow to. There's the basic pendulum-like motion that I showed. Asteroid hit here, and it did that. So there's that rotation that I'm noting. And the action of the East Coast refold is shown here. Okay. and it snapped back and everything that I was talking about. But if you look at the insert at the upper left, where I'm putting the check mark at, you see the arrows. Right now, where I'm highlighting, see where I'm highlighting? That is the one that goes along the back of that yellow fractal, okay? And it goes like into the border there along the St. Lawrence River. Now, the entire section of the northeast coast of North America, there's a little subdivision that's occurring here. And just like on the red pathway where it pushed off that one section, I said there was continental drift at the end of it into the little ocean there or whatever to the north. It caused the continental drift. Same kind of thing going on here. So see this action here just west of the Adirondacks in New York, and it sweeps around. So there's that push off there, and Nova Scotia this time was one that drifted off. All right. So you see like this counterclockwise rotation. There's another little one that happened by Prince Edward Island. All right. And I think there's another little tiny one here that I'm highlighting. See that? I should note, and I recommend that everybody look at this area where the yellow Refold fractal is. This thing is extremely clear, and it's really freaky to see. It's gigantic, very, very clear, but it actually looks like a dog with a tail, and the tail is, see what I'm highlighting? It's this part of the SC structure. So it looks like a dog with this tail sticking up right here. Check it out. Okay, finally, if we look at the chronology of this thing, looks like the blue fold, the center line of the fold shown, that formed first. Then the SC structure, which is shown in magenta, which pulled the blue fold. So obviously, that's that order. Then the C-shaped fault that apparently has not moved much at all. So I don't know if you could say it's a fault, but it's a weakness there. And that's the one that I said goes into the St. Lawrence River, and it goes along the back of the yellow Refold. Then the yellow fractal itself, which is always very recent anyway. In this case, the yellow fractal is unaffected by the SC structure. So sometimes things are related and sometimes they're not. But in this case, it's definitely related to the that fault line that goes into the St. Lawrence River. St. Lawrence River over here. So again, to reiterate, these recent fractals that are on the order of like thousands of years, they're just unaffected by any kind of brittle displacement and all that. They remain. The only thing that gets to them is the erosion, because the erosion could have been very recent, whether it's erosion or sea level rise or whatever. That's the only thing that gets them. Okay, this is Northern and Central Africa. Fractals shown there. And I drew in a red highlighter, I drew in the faults that are shown from this published study over here, showing the Great Rift Valley. You can see this red one here is definitely controlled by that fault system. And if you look at the other faults, like the one here, this one in the blue, the nose is going perpendicular, which I said happens a lot at faults, and this one's going parallel. The body, at least of this one, was parallel. This guy's got his nose going towards something else, maybe this other fault right here. And you see maybe possibly a general trend of these guys going up into the energy direction, which is the arm of Africa going in that direction, with the exception of this guy that I'm circling and this one right here. There seems to be a general trend of everything floating up in that direction. Okay, this Google Earth image that's marked up with fractals is Southern Africa, and I drew in the Great Rift Valley. You can see in the insert, I drew those faults in with the displacement. So what you can see here is the blue fractal that I'm checking. This one is definitely controlled by the faults. Even the red one looks like it's controlled by the faults there, and definitely the green one also that I'm checking. So what you'll notice here also is this is a fault system. So there's a lot of times these guys with the, by leading from their noses like these two here, there's probably a fault here that connects up as such, and there's probably a fault here that connects up as such based on this nose too here. So the value of these fractals is that they can detect some deep faults possibly that haven't breached the surface yet. Okay, these are a bunch of fractals in North America and the United States and a little bit in Canada. So what's going on here is, as you see in the upper left insert, there's the east coast of North America Refold Subdivision that snapped off between, where I'm showing in the highlighter, between New Brunswick, Canada, and what became Alaska. So that whole section, there's like a Boudin pathway in red that snapped, and you can see that slack that's developed and everything. We discussed this before. So in a sense, the whole Appalachian folded area where I'm checking now is a fault. So I did not see, at least on a couple scales that I looked, I didn't see any fractals in there except in the Poconos, which are kind of an independent thing. So you'll notice that these fractals butt up against the front of the folded Appalachian Mountains. And so they're going parallel, like this red one that I'm checking, the yellow one, etc. And there's a dynamic. You can see that they're turning. You can see this orange one that I'm checking. This guy, it looks like he's skating. He's going towards the zone in blue. This guy's really turning here. So there's definitely a gravitation towards the edge of that front, and they can't penetrate the front, so they butt up against it. Now, over in this area, in north central PA, the front actually turns. So that's why that these guys in red and orange are turning there, because they're going to follow that front this way. And something strange is like this independent, if you look at this guy, and this guy that are all related, they're showing sort of Rodinia after the moon was released with those legs up in the air. So anyway, there's this energy based on the headwind character of the front leg and the tailwind of the back leg. There's a force going like this way. So you see that. Not sure why that is, what's going on there. And even the yellow one at the bottom, there's some kind of force going that way because you have your front tail headwind bent and then the tailwind of the back leg as such, just as they are in the front, the top, I mean. Okay, just something to note here also on the bottom insert, there's this huge fractal in basically Ohio, and it's not seen on this scale, so that's just an example. For whatever reason, it wasn't seen when I drew all these together. Okay, these fractals are in northern United States on the East Coast and southern Canada, and some are pretty big, and they keep in mind that these guys are overprinting everything, going right over that that border of the North America subdivision on the East Coast that goes along the St. Lawrence River here that I'm highlighting. And actually, it looks like it's kind of cool. This one in orange here that I'm checking, it looks like his leg outlines Lake Ontario perfectly. So I'm not sure exactly what these guys are doing, but just speculating here. I think there's these faults that are all related in character that are related to like continental drift and counterclockwise rotation. I think there's a little one in here where I'm highlighting, and see the noses here are attracted to that. There was one that around Prince Edward Island here. So this one's, you know, the arrows are going this way counterclockwise. And then there's the one that goes around the Adirondacks like this. And I think this is the one that pushed off Nova Scotia here, which I'm labeling. So you can see some patterns here. There's some sort of, see how I'm drawing this red line in here. These guys are going somewhere for something. There's a general trend. I think the ones up here, like I said, that I circled, I think they're going right into that fault. But the general trend over here that I drew this line, where I'm making the arrow now, I don't know if they were has something to do with Nova Scotia or whatever, but they seem to be going in that direction. There seems to be somewhat of a discrete path there. And then there's this guy here. So I don't know. Are they all being drawn down like this over to where the breakoff was? See that? Okay, this fractal is in Canada and northern United States over by Minnesota. There's Lake Superior, and it's Hudson Bay at the top. So it looks like some interesting things here. It looks like there's a general trend to the right with this pendulum-like motion. And as you can see from this one in magenta, there's a little curl there from the headwind. This guy's going in that direction, and then this guy, which is a big guy, the yellow one, and even though he's big, his front cone is being bent there from the headwinds, I guess. And it looks like he's under strain, you know, from that turn from this pendulum-like motion. And it's causing like a clockwise rotation too. You can see that especially, or you can see it in the yellow one. And the blue one is really, see his leg there, so he's getting ready for a big turn. And even the magenta one, which is further away from the energy, he shows phases there with his feet. Went from red to magenta. You can see on this side here. And I think that's going on because, you know, he's getting ready to turn to the right and everything. So there's the left foot will turn a little from right to left. You can see the three-dimensional thing going on, the thickness to this guy in magenta. All right, what we got here is a gigantic fractal in yellow, Refold fractal. This is in North America, Canada, the United States also. And there's a littler one to the southeast in blue. You also see in red there's a ductile structure called an SC structure. Shows a clockwise shear sense. And I can tell you right now that the dominating direction of movement is along this arrow here. And that's related to the pendulum-like motion, which is shown by that arrow and as indicated in the text box that I'm highlighting now. That's from the pendulum-like motion of the asteroid, which landed somewhere around here, came down a little and rotated this way in a pendulum-like rotation. And then there's this rotation about that asteroid impact area. And there were some things that indicated that, such as this source where I'm highlighting now, source of the Mackenzie Dyke swarm, which is an igneous cluster of dikes, and it goes in a clockwise direction. And it kind of mimics what's going on in general. And I also talked about on a previous slide, several slides, about this discrete pathway that I showed in red, and it even pulled Boudins with it. So it goes something like this. It goes right through the SC structure as such, and then it comes up like this, and it pushes off the land over here. This came off of this right here. So it caused like a continental drift thing. So what I think was happening is this gigantic yellow guy was actually headed up this way, because you can see his legs are kind of going up that way, and then his back got pulled into this really, really powerful counterclockwise force going around the asteroid impact. And obviously you can see his front cone is going in that direction, and this guy on the bottom may be going in that same direction. It's far away, but it could be. A lot of times when I see fractals at certain scales, they're all doing something, all related or whatever. So in this case, I saw these two, and that might mean that they're doing a related thing here. So just as a reminder, this is still faulting. It's ductile faulting, but it's still faulting. And these refold structures, these fractals, are still controlled by the faulting. So that's real obvious right here. Okay, what you see here is fractals that are in mostly Mexico and southern United States. And there's an insert that shows the same area, the insert on the right, that shows the faults in the area. So what I did, I put them in red highlighter. And the one that's in pink, and shows the red dots in pink on the insert, is this fault here that I'm circling. What that represents is the border of the eastern subdivision of the North America refold on this side. And it's moving in this direction, in this area. and the other side over here is moving faster in this direction here. That's why I drew the arrow bigger. And so what happens is you get the drag fold, so it comes down more. I'm highlighting the Rio Grande. This is called Big Bend on the Rio Grande. And it gets pulled down. It's like a drag fold kind of thing going on there. So that's why it looks as it does. And it looks like in the main featured fractals here in red, fractal in red that I'm putting a check by, and the one in orange, they're definitely controlled by the faults here. One in orange is definitely along the refold boundary there that I was just talking about. The one in red is either controlled by, it's really one fault that joined up, so it's controlled by that fault system. You'll notice, as I just discussed, the fractals here are controlled by the fault system, and the ones in the insert are also controlled by the fault system. They're just different ones shown because different ones are visible on different scales. That's why you don't see the same ones in both of the insert and the main featured area. Okay, this is showing land use for Boudins, various refold fractals and Boudins in Rhode Island, USA. So there's a whole dynamic going on here that's shared among the Boudins and the outer space refold fractals. All right, let me read the text box, and then by the time I finish with explaining the diagram, hopefully it's clear. Okay, the various Boudins in this area are eventually jammed up at the beginning of the fault line path of flow in green. The original path of flow is along the same fault line, shown in black, for the Magenta Boudin. That's where it all started. Note that the colors of the Boudin positions are shared with other colors and are referenced as the tail color hereinafter. Very important, because that sharing is makes everything confusing. So just look at the tail. Due to the jamming up of flow, where the black line meets the green line, the Magenta Boudin likely moved to the position of the orange Boudin. So look at the tail. You see the orange tail. Then, due to later left lateral flow, as indicated by A, the SC structure, shown in red. B, the final brittle displacement of the green fault. You can see that snap there, that brittle snap. And C, the dragging and sticking of the tails of the Boudins along the vicinity of the red fault. The orange Boudin rotated counterclockwise to the blue, and then to yellow positions. The Boudin may have then relaxed to the final position of the green Boudin. Note that the smaller red Boudin is quite similar in character to the green Boudin and is likely just prior to the further relaxation. Note that the relationship between the Boudins and land use. Finally, note that the character of the outer space refold structure fractals can help to determine where the faults are located. Okay, so there's this Boudin path in black. You see that? I'm highlighting the one end of it here. And that followed to the path in green further along. You can see that on the left side. So the magenta fractal, see the tail here that I'm highlighting? Okay, that came along and started jamming up in the vicinity in that where the black path becomes the green path. So it started jamming up, as you can see, further deformation when it goes from the magenta to the orange here. I'm highlighting the orange. So it starts to buckle up there, and then it continues to buckle up with when it goes to the blue position. So there's a big force coming in this area, this basic SC structure here. It shows what's going on here. You see the yellow arrow? I'm highlighting the yellow arrow. That's the direction of movement. So just picture like a wind coming through. You see how it picks up that SC structure and everything? And eventually it's going to snap the, look to the left. You see that brittle snapping of the pathway? But what it's doing now, it's going to kick up these refolds. No, not the refolds. It kicks up the Boudins, I'm sorry. So it goes from the orange, as it's compressing, it's also kicking up. From the orange to the, really the magenta, to the orange, to the blue, and then to the yellow. See the yellow here? So it's kicking up from that force, and compressing and kicking up. and then it relaxes, so to speak. It springs back to the green position here that I'm highlighting. And there's also like a little phase thing going on here. This little red one that I'm highlighting now, that's just before, it's kind of between the yellow phase and the green phase. There's like a little more relaxation to go. It's got the same character as the green one in particular. So you can see these fractals are controlled by the faults. Now the black Boudin path and green Boudin path is basically a fault. It's just a ductile fault. So you can see the guys over here where I'm circling on the right end, they're controlled by that Boudin path. Some are right along it. They're gravitating to it though. And you can see there's also a red fault shown in red there, right through the middle of the whole thing. And these guys are, and this one too, they're all controlled by that fault there. You can see that. Highlighting the area now. You could see now where I'm circling, this orange guy is controlled by the red fault. And again, here's these guys that are controlled by the black fault, the ductile fault, the Boudin pathway. All right, and even the green one a little bit here. So if you look at the green pathway to the left, these guys were up against it, and now they're getting pulled into something here. Look at where I'm circling now. Looks like everything's gravitating to this like a hole here in the fault, like a particular attraction zone. So you see everything going into that. I mean, maybe even the rear end of this one that I'm circling in orange. See him? Looks like his rear end got pulled up into there. And his nose, his front cone, where I'm highlighting, he's kind of following that red fault. So you can see a sequence of events here. The Boudin flow line occurred first, that was shown in black and yellow. I'm sorry, black and green. Then the left lateral fault occurred, which is in red. You can see like a little bit of bulging here where I'm circling in the pathway, so that you can see the action from right to left. It's called a left lateral fault. And even the SC structure gets kicked up there. So after that, then there's that snap, brittle snapping, at least on the surface of that green pathway. All right. Okay, this is in Nunavut, Canada. You see a SC structure outlined in yellow, and the net movement is to the right, as shown by that arrow. The location of all this is shown in the insert right here where I'm circling, and it's showing that there's a fault line here. It goes right through the SC structure and everything. So what's going on is everything's getting pulled violently, and there's consistency here with the SC structure, between the structure and the fractal. So it's kind of funny. It looks like this green guy's back is going to break. There's so much force getting yanked into that fault zone parallel to it. Okay, this is in a bunch of refold structures in Ontario, Canada. And there's a lot missing in this view, and I noted in this text box that there's a ton of them to the west. So it's just a fact. For whatever reason, there's tons to the west that are not shown in this view. And as I said, there's a bunch in this view that I do not show, just not to clutter it up. But I want to show here what happens around a fault line. So there's a fault line that comes through here. Okay. And check this out. This is really cool. I'm going to read the text box first and explain. Attraction zone with lateral and clockwise fractal movement into a fault, demonstrated by the red, yellow, and blue color coded fractals in this area. Okay, so what I'm talking about, see that fault zone in red that I highlighted in red? Check out this guy in red here, and this other one. That's the same dude. He looks like, look, check out his legs here. He's really getting pulled over to the right. And you know it's going that way just based on, again, the way his legs are. And this is like a tailwind thing here on his left leg as he gets closer to the fault. and a headwind thing here on his other leg that, you know, kind of comes up. So you can tell that action is there going to the right into that fault zone. And if you look at the yellow guy here that I'm highlighting the top of his cone, he becomes this yellow guy here that's right along the fault. He's parallel with it, riding right along the fault. And if you look at the blue one here, that's sharing a border with the red one too a little bit. So that blue one becomes this blue one. I'm highlighting the top of his cone now. So you see that rotation this way. So there's that lateral movement that I talked about here. And there's the rotation here, this clockwise rotation into the fault zone. So that's what's going on with these fractals. Something interesting, if you look at the yellow guys on the bottom that I was just talking about. So if you look at this guy in yellow, I'm putting a check there. See how skinny his leg is on the left side. All right. So I thought I screwed up. I said, why is his left leg so skinny compared to his right leg? You can see that, right? And then when he goes at this other phase later, now you're just looking at him again. He's facing the other way. This is still his left leg right here that I'm highlighting. So no, there was not a mistake. It's still showing skinny here, and apparently it's the same guy, or a damn close relative, but I think it's the same guy, of course. I think that's what's being demonstrated here. Okay, these are refold structure fractals with cones present in New Mexico, Texas, and Oklahoma, USA. So I'm highlighting a black line here on the right side. What this represents is the borderline of the subdivision of the North America refold on the right side of this black line, and on the left side is the remaining part of the North America refold. So you can see that North America refold in the insert on the lower left. It's outlined in blue. So over here where I'm highlighting, New Brunswick, Canada, was connected to what was Alaska, and it snapped off in tension. Alaska went counterclockwise, and the refold subdivision got kind of compressed in its northeast end. And you can see that Boudin path when it was under tension, Boudin path in red, it snapped, and you can see slack developed and everything. One area where there's slack is where this slide is showing, and I'm highlighting in the blue. That's what I just outlined in the black line. And so that Boudin path is kind of mimicking it to some degree here that I just outlined. That's shown in red, that Boudin path. So what I show here in the text box, I say the red and green colored refold fractals appear to be attracted to a zone, which is that fault zone. And the green refold is squeezed into the zone. Now keep in mind the red may be the same as the green. I'm not sure. It could be a phase kind of thing. The zone is a fault zone at the border of the eastern North America refold, which was connected to Alaska and area, and prior to snapping off under tension between 100 million years ago and 75 million years ago. So they were connected as it described in the insert. Fault zone is shown in black. Okay, should also note that here's the Red River. There's actually a fault here, as you'll see later. So these guys are going parallel to it. They're attracted to that fault zone. Okay, these are refold structures in Northwest United States. As you'll see on the next slide, you're going to see other ones with a different scale. Now, the one that's unique here, pointing out here, this fractal is similar in character to the Russia refold. So the Russia refold, one outlined in blue, that's actually a subdivision of Rodinia. The original Rodinia was shaped as such. So I'm drawing a picture here on the upper right. And remember, this was subdivided. And actually the Russia refold was at the top. This part of the chain didn't make it to the inner Earth, but Russia's up at the top here. So that's what we're looking at here. And today, Russia looks similar in character to what's shown in here in blue. And there's a lot of force going into it, as you'll see. Okay, in this slide, we also see the same area that I just showed in the previous slide. It's just a different scale. You see in white here, where I'm checking this refold structure outline in white. This is the one that resembles the Russia refold, and there's I said there's a lot of energy going into it, a lot of attraction. So you can see that going on here. So these refold structures look like they're attracted to something all up and down this whole entire area. I call them heat-seeking refolds, and there's a reason for that you'll see in the next slide. Okay, this is the same slide as the previous slide, and you can see all these refold fractals are attracted to a certain zone here, and that zone is that fault, which is in red. This is a fault that goes through Yellowstone National Park. I said in the text box here, there is a suction fault zone in red that attracts the refold structures, which includes Yellowstone National Park. So this fault is related to the Alaskan area that snapped off of New Brunswick, Canada. So it's that segment, that arm that whipped around counterclockwise, and now it's moving in this direction here that I'm showing in an arrow, and it's going towards the towards Central America, towards the Yucatan Peninsula and all, heading that direction. So there's a huge fault there. These guys are like heat seekers, like I said. They find that heat, that access to the center of the Earth along the weak spot, which is the fault, and they want to get down in there. Okay, these are refold structures in Australia. And on the insert, I'm showing a published geologic map where there's some brittle faults shown in black and light black lines. So I believe I refined the published map with extending some of these faults and showing additional ones and really what might be going on here. So as you can see, there's a, if you look on the insert, there's a fault here. So I'm saying in this text box, the large fractal below in yellow, which is this one I'm checking, is cut off by the fault shown in red, as much of these fractals typically do. It is likely that the fault shown in black to the southeast of the arrow continues further to the northeast. So this is where it continues here, this zone, versus what's shown in the map. At least the depth it continues. I've said this before. So these faults, maybe they're only mapped on the surface as shown in the insert to the left, but at least at depth where they might still be ductile could be shown by the indication of the character of the fractals. So based on the character of many of the fractals in the area, not all shown, the fault system is shown. So I use the word system to kind of characterize this better. So the ones that are on the surface are just expressed, and the system is below, which could include like ductile faulting. So in fact here, a drag fold is kind of a ductile fault. It looks like there's a drag fold here, highlighting here where that drag is now. You can see there's an SC structure here, and there's an indication that the direction is that way. So apparently this fault was more straight, and it got dragged like this by the action as indicated in the SC structure. So you can see that this got pulled up, got dragged upwards. You also notice a few things. It looks like there's like a hole here that everything's attracted to. In particular, look at these guys diving in on top. This is a strange one in yellow. I checked that a million times. It's like a worm. Kind of lost the top hat or something. I don't know what the heck it is. But anyway, there it is. And interesting, very interesting dynamic here. You can see these fractals on the left side are, some of these are going parallel to the fault. And this guy here in blue is going perpendicular. This guy is going parallel, perpendicular. These guys are headed towards something here. Check this out on the bottom. This white one here and the red and the blue. You see the blue? Okay, so they're all going this way. What the heck is down there? I'm not sure, but that's where they're going. I mean, that's where Australia had broken off at one point. Broke off of Antarctica along, check out the insert along this coast. Used to be attached to Antarctica here. But ants. So, I mean, I don't know what these things are attracted to, but they're going that way. And you look at the bottom, these guys are oriented along the fault here. Well, this guy's going maybe perpendicular. It depends on how you look at it. But there's definitely, the character of these refolds are definitely determined by the fault locations. Sometimes, actually it happens a lot where things could be heading in different directions, but as long as they're going parallel to the fault, that's the whole point. See this guy in red here, I'm highlighting the cone on the left side here. He's going that way, and the one in pink is going that way. So you see that a lot. Okay, this is a fractal of the early Earth, and it's in Australia about 875 million years ago. It's sort of like the Theia impact. The chain structure consisting of several subdivided refolds. There were the 7 landmasses I talked about, all lined up in a chain. I call the Rodinia chain structure because there's 7 subdivisions, and 5 of them are seen here. But the Rodinia supercontinent just landed on Earth as like the Precambrian crust, and you can see 5 of the refolds here around the corner. North, you could say, of Africa is North America and Russia. So what's going on here is the Southeast Asia refold is right now it's sort of part of the early locking mechanism. I just put a check on the one arm, check on the other. These arms have yet to go down to the inner Earth and suture to it, and then really the locking mechanism developed. So this is like an early stage, like a Theia impact thing, and there's a lot of activity going on now, and there's areas of this globe that are exposed to attraction because the system is not fully closed around the globe. And I think that what's going on is these fractals are finding the heat, finding the exposed areas, and they're attracted to it. See, I'm circling where they're headed to. As this guy gets further away, he's going elsewhere, wants to check out something else. But these guys around the corner here, they're going to that flow. They're all going to something around the corner here. So there's a hot spot there that they're attracted to, and then they can access the inner Earth where it's hotter and the gravity brings them in and everything. So you see these guys also, I'm circling the cone here. Incidentally, you see these fractals are formed by on the coast and everything, and there's lineations in the water that form the outline of this yellow one. You see the little tiny red one here. This green guy, they're all going into that attraction zone here. Just drew an arrow. Just something to note, I have on the inset there's a fractal after Rodinia broke up after the asteroid impact, and this is 550 million years old, at least at the bottom, so it's at least that age, because the time goes older to younger from top to bottom as such. So looking at that insert, you can see the shapes of the refolds, the subdivided refolds, and some of them have the same shape basically. It's just been inherent since a long time, as you can see. I mean, in particular, for example, look at Antarctica, which is right here. I'm highlighting on the insert, and right here above, you can see that it's got that hump and everything, and then Australia is on the right side. Okay, so you see these shapes just keep kind of remaining the same in a lot of cases. Okay, what we got here is another fractal in Australia, early Earth. Basically, we're really starting to form the locking mechanism now. There's just a little bit more to go. But as you can see, the Southeast Asia refold arms have come down. I'm highlighting the one arm right here. And the other arm, looks like there's a hole there. I'm going to be careful here to not screw up everything in this diagram. But you see the edge of that arm there? It's not out as far as this one is. This one's really got the whole locking mechanism zone covered, so to speak, whereas there's like a hole on the right side. And there is, in fact, this is the South Pole where all these fractals are, the little guys. So there is, in fact, a gravity anomaly in the South Pole today. So I can see why there is, because I think something happened here. I think this is responsible for it. So these guys, there's a bunch of them. If you look carefully, they're all diving into that open zone. And sure enough, as you get further away from the open zone, for example, look at the white one here and this pink one. They're not concentrated yet, at least as to getting into that zone. It's possible that they come out and then back in, or they would do that, so to speak. But all these other guys, they're all going in there. They're all attracted to that zone. All right, this is kind of cool. Lots of Refold fractals, big ones, little ones. They're all over the place. And this is Europe and Asia. So I'll discuss more in the next slide. This is just an introduction here. Okay, what we have here is the same slide as the previous, with the exception that those black lines are drawn in, and those black lines are drawn in on the edges of refolds, such as the arm of the Africa refold, which is over here, and predominant movement was in this direction, and the Southeast Asia refold is over here, so it's sharing that border, you can see, and there's that bonding, that sticking in that zone in where it's in contact over here where I'm circling. So that's important because, you know, when the arm moved this way, then the Southeast Asia refold stuck to it and moved that way and made a clockwise rotation, and vice versa. At the end, there's some evidence that it went this way a little bit, and then there was counterclockwise rotation of the Southeast Asia arm. So that all factors into tectonics. But it basically performed this balancing act, as you can see, and you can get your bearings in the insert on the lower left over here. I just didn't draw in the Russia refold in yellow. And I should note that it looks like there's like a hole there shown in black between the Russia refold in yellow and the arm of Africa. It's not literally a hole. This is just down deep, the ductile refold structure boundaries here. So there's younger rocks that have filled in the gap and everything. So while performing this, what looks like the balancing act shown on the insert and discussed before, the arm of Southeast Asia refold, which is over here that I'm highlighting, comes down this way and it goes to just south of India. It connects to the inner Earth at below the equatorial spin axis of the Earth. And every time the Southeast Asia refold rotates, it breaks up the brittle zone above and causes like more attraction to that true zone, the source down there at the inner Earth. That's the true source. But through the broken zones, there's greater attraction, especially if these segments of portions of land and you know, the original 7 land masses and all, when they are moving around, they'll feel it more as they move out laterally. They'll get pulled into it more. So one gravity anomaly was resulting from the anchor of the Southeast Asia arm. As it moved around, it made the brittle crust less dense in that zone near the equatorial spin axis, and that's one gravity anomaly. As I talked about previously, the other is inside the to the north, just inside the Africa refold arm. So those are those sort of access zones to the ultimate goal of getting into the suture where that arm connects at the equatorial spin axis. So I'm going to read the text boxes now. Up here on the upper left, refold fractals are attracted to the suture zone, where the northern arm of the Southeast Asia refold, which I highlighted, is sutured to the inner Earth at the equatorial spin axis. Access to the suture zone is at 2 locations, one at the north side of the Africa refold arm, underneath it, and at the other at the south side, which I just explained by the equatorial spin axis. Additional refold structure fractals are attracted to the south side of the Africa refold arm, are shown in a separate drawing on the next slide. Okay, on the right, I just a little note here. There appears to be phases of refold structure fractal attraction to the suture zone. One phase appears to pull the fractals into a distinct zone from all locations and shows some degree of superposition of the fractals in the distinct attraction zone. This fractal that I'm pointing to on the edge there appears to be distorted because of the curvature of the Earth and is not being pulled into the suture zone because it's so big. Sometimes these things don't feel the attraction or whatever. It really depends on a lot of things. Sometimes there's a hole big enough and it still pulls it in. So a lot of factors. For example, I think one of those holes exists, and it's probably tied into that gravity anomaly, which is underneath the arm. But check out this area here where I'm circling. So you see how they're going in. You see those guys over on the left side. They're moving into that zone. I'm drawing an arrow here. And look at the white one here and the green one. They're all moving into the zone, into that hole. So that hole that I was just talking about where everything's going into, that's the one phase I was talking about in the text box at the right. So this is pretty cool. Check it out. There's more to it than you think when you take a really close look at it. Really interesting stuff here. Okay, these are Refold structure fractals in China, and where they're shown is in the red highlight on the inserts, the upper left. See that? So what I did, I put in red highlight on the main featured fractals here. That is the border of the Southeast Asia Refold, and you can see from the previous slide, there's a lot of sticking and all that. There's obviously a bond and everything going on with the arm of the Africa Refold. And predominantly the movement from the Africa Refold arm has been in this direction, which I'm showing. And what that means is it's going to pull the Southeast Asia Refold in a clockwise direction because of that sticking. It's going to pull it right with it. So you get a clockwise rotation. And you can see that in probably this yellow guy at the bottom, this little guy here that I'm checking, the yellow one here, and the blue one. Now I also claim that there's some later counterclockwise rotation, some movement the opposite of what I just described. There's some counterclockwise rotation in the Southeast Asia Refold because the arm of Africa actually retracted, and it did like what I call the balancing act, as you can see in the insert. So it actually went this way, the arm went that way, and it pulled. So it went that way, as I'm showing, and then it pulled the Southeast Asia Refold with it. So then it went counterclockwise. So possibly this guy in red, I'm circling the cone tip, he might be going counterclockwise. And also based on the character of the Southeast Asia Refold, where I'm highlighting now, there's a little bit of indication there could be some counterclockwise motion there. You can check that out on a larger scale in another slide, or check out Google Earth. Okay, this is showing south of what we just showed. This is basically Asia. Refold structure is shown there. I don't want to say too much yet until the next slide. Okay, this is the same slide as previous. It just shows the, in the black lines, it's the borders of the Refold structures. For guidance, you can use the insert down here on the right. So you got the Southeast Asia Refold here, you got the arm of the Africa Refold here, and you got India over here. So you'll see that there's definitely a sticking, a bonding between the Southeast Asia Refold and the arm of Africa, you know, based on this character of the black line here that I'm highlighting. And I didn't show the great detail as I did in another PDF and all, but there's definitely that linking. In other words, when Southeast Asia rotates clockwise, it's because the arm of Africa is going this way or whatever, and then it pulls it. That's what I was saying before. And then it rotates it counterclockwise, excuse me. So there's been a lot of clockwise rotation, and I noted, as you see in the insert here, in the heart of China, now that area is like over here. So I was saying that there's a lot of fractals in here. For example, I'm circling the noses of at least 4 of them. I think this guy comes up and around, and this guy here. So there's clockwise rotation going on. And that's also shown with this guy in red. Very interesting character here. Looks like he's got muscles and flexing and everything in his lower body. Looks like his back is breaking going in a clockwise motion and everything. You see, like, again, there's fractals that are going into like holes again in this area here. You see they want to head down into a hole, drawing an arrow. And even some pretty big ones, like over here, disappearing into the fault. There's one in yellow over here below where I'm circling. Pretty cool stuff. So this guy outlined in blue up here where I'm checking, he didn't get pulled into a suction zone, into a fault zone, but his body borders the fault zone and everything, as you can see. Okay, refold structure fractals with cones present. Ohio to Louisiana and west, United States and Mexico. I'm going to get into details on the next slide, but just check some of these guys out. Look at this one in white that I'm highlighting now. See the highlight in kind of the west? Really, really cool stuff. Okay, this is the same as previous slide. This is Ohio to Louisiana and west, United States and Mexico. I just drew in the faults based on the character of these refold structures. They're like little Rodinias with the cap still intact, the top cap and everything. And again, they're based on the character of these, which are the energy is guiding these cone sections, and the refold structure fractals are either parallel or perpendicular to the fault line. So I drew the fault lines in. There's like a system here of faults, and it all makes sense. There's rhyme and reason to this. So let me read the text boxes. Okay, this one here. Based on the character of the fractals around the fault's suction zones, it appears that the fault through Yellowstone National Park, shown in red, branches off and joins the San Andreas Fault, which is in blue, continues to the south, to the west of Big Bend of the Rio Grande River, and has fault splays to the east, resulting from the counterclockwise rotation of North America. Alaska and area snapped off from rotational tension off New Brunswick, Canada, approximately 100 to 75 million years ago, and Yellowstone National Park is on the edge of the fault zone. Another fault suction zone that attracts fractals is shown in black, where the North America refold joined at a suture to itself after rapid and severe counterclockwise rotation of the refold at approximately 475 to 500 million years ago. That's when that severe rotation started anyway. The third fault that is shown in magenta and black in the insert remains on the east coast after Alaska and area snapped off New Brunswick as described above. Note the drag folds from the snapback in the Great Lakes. Fractals move either parallel or perpendicular to fault zones at the locations of the fault zones. Fractals are led by their cones towards such zones and end up parallel or perpendicular to the fault zone. That's what I described before. So looking at this inset here, a section of the fault zone at the border of the eastern North America refold subdivision is shown below. This was a slide we discussed before. Okay, we got the New Madrid seismic zone here I'm circling. All right, there's a weak spot here in the Mississippi River, so it formed a kink there. Mississippi going this way. So that's why the magenta colored fault, which is the border of the refold subdivision, it's shaped as such because this section snapped down like this after it was released in tension, as I discussed. So there's some slack in the border, and we discussed like that the Boudin path, as shown in the previous slide, that snapped and everything. There's slack, and the border of the refold subdivision mimics the snapped Boudin path and everything. I'm just going to highlight, just for the information, where the Rio Grande is here. See where I'm highlighting? Border of Texas here. So that's actually a drag fold, as I described before, where this went faster here in that direction than this side. The subdivision refold went not quite as fast, both going in the same direction, but this guy dragged relative to the other, it dragged it down as such. So these drawings showing the faults and all these zillions of fractals, refold structure fractals, took weeks. It's a lot of work. Okay, as before, I'm not going to talk much until the next slide, but refold structure fractals in northern and northwestern North America. Little Rodinias again, they're all over the place. I suggest you really check these out like in detail, blow it up in PDF and everything. It's really, really interesting stuff. I forgot to point out a couple individuals on the previous slides. They're really, really wild. So just kind of scan through it and you'll see some really, really human-looking ones. There was one in white in the southern half of North America in that one slide I forgot to point out, but it's really, really cool. So this one also took several weeks to develop. And some of them came alive again on certain scales. And it was just rough, very, very rough. And I'm very confident in how I outline these and the accuracy and everything. And you'll see it actually makes sense when I draw the faults in, so I know they're accurate. Okay, here's all the faults drawn in based on the character of the Refold fractals. First I'm going to read these text boxes, and then I'll talk more in detail. So over here, approximate location of source of the Mackenzie Dyke swarm. I talked about that in another presentation. So there's a lot of probably counterclockwise rotation from that source zone around the impact site. There's like a radial thing going on with dikes and everything, igneous dikes going in around the impact site. So they all kind of originate at that location. So look at the faults there, very, very similar, and the fault system, very similar, so it's all related. Okay, over here, example of where fractals are disappearing into a fault suction zone. Well, there's many of them. And again, this took a lot of weeks, like I said. All right, this text box. The source of the red faults are the tensional release of Alaska and the area off New Brunswick, Canada. The source of the dark blue faults are the tensional pulling of the land from the counterclockwise and pendulum-like movement of the asteroid contact area. The black faults are similar to the blue, but are related to compression. The westernmost black fault is likely the suture resulting from one leg of the North America refold kicking up and rotating counterclockwise and meeting the other leg. Remember, that started around 475 to 500 million years ago. The magenta fault is the result of compressional release. That's way up on the northeast corner and resulted in continental drift. Solid fault lines are the more obvious faults. So I put it in dashed where it wasn't quite as clear, but I'm still pretty confident in it. And the overlapping is the solid lines and the dotted lines. You'll see different colors. It just means it likely fed into it and became one fault. So it's basically like a conveyor belt system of faults. And the famous San Andreas fault is the edge of the rotational zone of North America, the refold structure. That's why it's so severe over there. So that San Andreas fault is shown way over here in the corner where I'm circling. So it goes to the south. It goes out in the ocean at this point. But it's all related to the system, as you saw on the other slide showing the southern half of North America. Okay, if you look up northwest of Hudson Bay, it looks like you got this source zone of the Mackenzie Dyke swarm, and then you got a tensional pulling in this zone here, and then it comes together to a pinch point in this area. And actually, remember those? You can see those two twin fractals that I showed of in Hudson Bay over there, and they're related to a fault zone here. This is the edge of the North America refold in black. So it folded upon itself, and that's why it's pinching in there on that refold border, and just where the crotch is and all that. So that's why it's allowed to come to the pinch point. It kind of compresses in that zone where these two twin refold fractals are in the water. So you got tension over here, and you got compression over here where the twins are. All right? With a little bit of twist, kind of trying to work its way back to that source, ironically. So the same dynamic is happening on the other side of the black line, which is the other side of the North American refold. So it comes up to the crotch in the this area of the twin refold fractals in the Hudson Bay. So the right side here is the one side, and that's the other side of the boundary where the North American refold kind of flipped itself over its back. So you have a tensional dynamic on the western end of this part of the refold structure, I'm sorry. So you have tension on the western end. You got that pulling over here. from that pendulum-like rotation here that I'm highlighting. And then eventually it comes to a pinch point, which in a sense is compression over here. It can't go any further. There's like a front here because it can't rotate anymore and it stops. And that's why you have the Nastipoca arc thing going on. It just stops there. I should note that this flow where everything pinches together, part of the path is over here where I'm highlighting. And that's through or in the vicinity of that pinch point of the Great Lakes rotational signature, which is in here. So I guess the path of least resistance, I could see why it goes through there. I mean, you got one regime going on over here, the real rotation. You got the pendulum thing going on at Lake Superior on that side. So between it is the path of least resistance. So I was talking about that discrete flow zone before, and I'm highlighting where it is. It's along this joined up fault zone that I don't know if you can see where I'm highlighting, up to the north and east. So what it does is it comes through and it has enough sort of power to push this off over here. Again, this was attached here. It pushed it off. Continental Drift. So again, this whole flow regime, so to speak, this ductile flow regime, rotation and everything, where there's a pulling, a tension into a compression at like a pinch point, that's mimicked by that red discrete zone of flow that I talked about on a previous slide. And it's really kind of mimicked by the flow of the igneous dikes from the Mackenzie dike swarm. There's that counterclockwise rotation, at least in respect to the Mackenzie dike swarm. All right, finally, conclusions, the moment we've been waiting for. Anybody that just jumped here without looking at the details, please go back and check it out, because you're really going to find the support back in the details. All right, number one, the Earth's Precambrian era crust, Rodinia, originated from either a planetary collision or a tremendous asteroid impact on another planet that was much larger than Earth. 2. The Precambrian era crust of the Earth is part of a chain of crescent-shaped to more tightly folded arch-shaped refold structures, such as Southeast Asia refold, that was pulled onto what is now the inner Earth and latched onto the inner Earth at what is now Southeast Asia. 3. The crustal impact onto the inner Earth may have initiated the rotation of the Earth to the east along the equatorial spin axis. 4. The Earth's Precambrian era crust stabilized by forming a locking mechanism at each of the poles. 5. A huge asteroid struck the Earth at what is now Canada and initiated tectonics by breaking up the locking mechanism at the poles, disrupting the refold chain's structure's path along the equatorial spin axis and eventually derailing the train of refold structures. 6. The Southeast Asia refold structure is still anchored to the inner Earth from one of its arms and still controls tectonics. All right, conclusions continued. Number 7. The oldest fossils on Earth that are found within the foundational rock of the refold structures are from another planet where Earth's Precambrian crust originated. Number 8. This model can explain all major chronological geologic events. Number 9. This model is structured, ordered, and consistent. Number 10. This model explains many geologic mysteries such as tectonics driving mechanism, the Nastipoca arc in Canada, microcontinent of Zealandia, microcontinent of Greater Adria, hotspots in general, Bermuda, relative ages and ages of the Earth's layers, gravity anomalies, magnetic anomalies, the mid-continent rift of North America, the North America Mackenzie dike swarm, fault system interrelationships such as the New Madrid seismic zone, and even the Theia impact. Number 11, this model can determine or verify faults, fault systems, and fault interrelationships for brittle and ductile faults. 12, this model does have some complete agreement with the existing model, and where it is not in agreement can explain the reasoning of the current model. Number 13, this model is verified by and guided by the discovery of many amazing fractals in North America and around the world. Okay, The value of this study. What is the value of this study? 1. Safety for humanity. This model can A. Determine fault locations and their interrelationships. B. Determine what faults to prioritize or focus on studying. And C. Refine climate change studies and other studies related to the well-being of humanity and the fate of our planet. 2. Economic prosperity. This model can determine and refine locations of Earth's resources that are valuable to the economic prosperity of humanity. And 3. Preparing for the future. This model can explain all major chronological geologic events. We can learn from the past because it is the key to the future. Okay, well, this day and age, as we all know, there's all kinds of agendas on many levels, lots of manipulation of people because of these agendas or whatever. There's indoctrination, censorship on many levels, all contributing to people's belief systems that it's going to be something that makes it difficult for me to get any traction on this study. But I'm asking anybody that checks this out, and you have to look at it in detail. And if you do, you're going to see that I nailed it. But anybody that checked it out and saw this, please spread the word because I need all the help I can get. And in conclusion, I know that there's 2 souls that know that I'm correct, that know, not believe, that know I'm correct, and they're listed here.